Okay, in this question, we're going to sketch the graph of a polynomial function given the equation. Given now what we know about roots and multiplicities and what it might look like at those points, at those roots with even, odd, or simple multiplicity. So let's do a sketch, and then we'll just graph it in Desmos to compare what our sketch looks like, and just see how good our sketch is based on this information. So let's see. We know there's going to be a root at 0, multiplicity 1. So I'll put the roots in blue. Okay, so there's a root at 0. There's going to be a root at 1, positive 1. Okay, so I'll put a 1 here. This is 1. And actually, let me move 1 a little closer. Put 1 here. Okay, this is 1. And then negative 3, there's a root with multiplicity 2. Okay? So we know there's a simple multiplicity here, right? That looks like a line. We have a odd multiplicity, right? Which gives us something that kind of might look like that, right? Or the reflection of that. And we have an even multiplicity, which is going to look like maybe a turnaround. Okay, so and also we know this is going to be even, right? It's even polynomial with a leading even power function as the leading term, because if you multiply this out, it's going to be x times x cubed times x squared. That's going to give you 2x to the 6th power is the leading term. So we know it's going to go up to positive infinity, right? So let's say we're going to graph this thing, right? So we have the zeros. We know their multiplicities. We know, let's say it's going to come down, right? Let's say it's going to come down from positive infinity, right? And it's going to hit 3 and bounce off of 3 because it's an even multiplicity. It's got to come back up here, but then it's going to be a simple line through the origin, right? And then it's going to go down and then gradually come up, right? And gradually go through the x-intercept to 1, right? So something like that, maybe, right? That would be a decent sketch for this. And, ultimately, I mean, ultimately this is going to go, towards positive infinity again at some point down the line. So let's take a look in Desmos and see if we, what it looks like, how it compares. Okay, so I'm just going to type the function in. F of x is 2x, x minus 1 squared, actually cubed, and x plus 3 squared. Okay, so, well, this looks a little weird here, but it's because of the scaling. So what you can do is you can hit shift, and you see how the axis turns blue. You can kind of rescale it to see if your sketch looks anything like it. And you can see it kind of does, actually. Let me take a snapshot of this and bring it into our notes and see how they compare. Well, you can see, while it's not, perfect, it actually has the right shape, right? It comes down from infinity, bounces off, comes down from infinity, bounces off, has to come back up again, and then down through the simple root, right? Up again, down through the simple root. And this kind of gradually comes up and goes to positive infinity there. So we did get the right shape, okay? All right, let's take a look at the next one. Oh, this is a good one too. So we have a polynomial of degree 4 that has a root of multiplicity 2 at x equals 2. Okay, so we know our polynomial is going to have this factor in it. It's going to have So p of x, we know it's going to have x minus 2 squared, right? Minus 2 has a root of 2 with multiplicity 2. It's going to have roots of multiplicity 1 at x equals 0. Well, that would just be x. And then a multiplicity 1 at x equals negative 2, which would be x plus 2, right? So we know our polynomial is going to look like this. I'll just rearrange it in kind of order of multiplicities here. Okay. And we are also given another bit of information. We know it goes through this point. So in other words, when x is 5, right, the polynomial at 5 is going to be equal to 2, 5, 2. Okay, so that means there may be some constant term added here, right? So maybe we're translating this somewhere. So let's say plus some constant term c, okay? Well, how can we determine that constant term c? Well, we can just substitute x equals 5 in, and we know that it should be equal to 2, 5, 2, right? So let's see what happens when we do that. So we know 2, 5, 2 should be equal to, when x is 5, right? It's going to be 5 times 5 plus 2 times 5 minus 2 squared plus c, okay? So we get 2, 5, 2 is equal to 5 times 7 times, this is going to be 3 squared plus c. So we get 2, 5, 2 is equal to, that's 35 times 9, right? So what is that? That's going to be 270 plus 45 is 315 plus c. And now we can solve for c. So we can subtract 315 from both sides. So minus 315 minus 315. Okay. And you'll get c is equal to what? It's negative 63. Okay. So the formula now is going to just, well, I should say plus c. The formula will be this, just plus or minus 63. So I'll write it out here. So p of x finally is going to be x times x plus 2 times x minus 2 squared minus 63. Okay. You don't have to multiply it all out. You could leave it just like that. Okay. Let me know if you have any questions about this. Thank you.